Hello, my name is Mohammed, and I will be demonstrating the steps we took to complete phase one of this project and launch our web application. So during phase one, I will be setting up a virtual private cloud, subnet, internet gateway, a routing table, and at the end, I will be setting up an EC2 instance. So step number one is to set up the virtual private cloud. Uh, a VPC allows us to define basically our own isolated networks within the AWS environment, where we can launch other resources like EC2 instances. So you'll just search VPC, and then you can click here on the interface. After that, you will select Create VPC. You will be introduced with this configuration interface. So you can enter first your VPC name. So here we can have web VPC, for example. This IPv4 CID block is basically defines the ranges of all IP addresses that can be accessed through your VPC. So right here we can see we have around 65,000 IPs. The number of availability zones that are provisioned through the subnets. Here we have the number of public subnets, which are usually used to access stuff like web application. That means these subnets can be accessed through the internet, and the private subnets cannot be accessed through the internet, and these can be used to have back-end resources deployed, for example, a database. So after you have completed all of this, you can also have your own custom configurations. You will simply click on Create VPC. So as you can see, our web virtual private cloud has been created here. And the reason we need to create a VPC first is because every other resource, such as the subnets, gateways, and routing tables, will be associated with this private cloud. So now we'll move on to the next step, which is a subnet, which allows us to divide the VPC's IP range into smaller segments, and each subnet or segment will be tied to a specific availability zone. This ensures that our resources can be distributed across multiple zones, which will reduce maybe like fault tolerance. And we can utilize like the difference between public subnets and private subnets. So you can go in the same interface here to subnets, and you can click on Create Subnet. You will choose the VPC that you just created, and it will display the range of IP addresses you can access. You give a name to your subnet, for example, subnet VPC. If you have any availability zones that you prefer, and then you can enter the CIDR block. After that, you can just click on create a subnet. Obviously, I can't create this subnet because we already have a subnet with this subnet block. So it will show that it's conflicting and it will not allow us to create a subnet. As I just stated here, it shows this. And that will be all for subnet. So the reason you would want to create a subnet next is because a subnet is like lives inside the VPC and inherits their IP range. That's why you would create a VPC first, then a subnet. So after we have finished creating our subnets, as you can see here, some of them are subnets. And the reason we create a subnet after a VPC is because it needs like an environment. So we create the VPC as an environment and then the subnets. After that, we would create an internet gateway, and this component, it like provides our VPC with internet connectivity. It basically allows our VPC components to access the internet, and through it we can open our EC2 instance later on directly through an IP address or through the internet link. So you basically go to an internet gateway, and then you can click on create gateway, call it gateway VPC, and you simply create. On the gateway, once the gateway is created, it must be attached to the VPC. And this attachment is crucial because the gateway enables the resources from in our VPC to access the internet. So as you can see here, it shows attached to a VPC. We can just click attach to a VPC. And then our recently created VPC will show up. Click on it and we can just attach it. And that is it for creating and attaching a gateway to our VPC. So after attaching the internet gateway, we create a route table, and the route table defines how traffic is routed between our subnets and the internet. For example, it ensures that traffic from our EC2 instance that we will create later on can flow to and from the internet via the gateway. So things can come in and go out. Basically, you can go here to route tables, and then you can click on create route table. You can give it a name, route web, for example, and then you select the VPC that we have just created. And basically the default route is 0000, and this directs all traffic through the internet gateway for an internet-bound traffic. You just click and create route table. And once the route table is created, it must be associated with the public subnet we created earlier. This association is critical because it enables the subnet to use the route defined to reach our internet. So we can go here to our route web, and we would later associate it with the subnet. Unfortunately, we couldn't create the subnet because it was already used by our original subnet. So after you would have created the route table, you would associate it, and that would be it. So finally, we finished all the setting up of our VPCs and our network environment. We would now launch our EC2 instance inside our subnet, and this is like the computing source of our web application. It's like opening another virtual computer, but not on our local device on the cloud. You would click EC2 and you go to the EC2 interface. And then you would go to instances because you want to create an instance of this computer or virtual image of computer in the cloud. You would click launch an instance. You would give it a name, for example, Momo instance. And then here you select the operating system, which your instance or virtual image would be based on. It is very recommended that we use Linux since we are going to access a web application, specifically Linux 2. So this is what we're going to be selecting. And then you select T2 Micro as it is in the default because it's a free tier eligible. Here you have a key pair. So this basically is like a secure way to connect to your instance. Can create a pair and then it will download for you a file. And this file, you can use it to access to connect to the EC2 instance. After that, you can connect to the network settings. You can here create a security group. For example, we would allow HTTPS and HTTP traffic from the internet. Anywhere here means that this instance can be accessed just by simply putting in the IP address from anywhere. If I would have clicked, for example, my IP address, it would only allow access to or connection to the instance only through my IP. After that, we can, for example, edit the security settings. These are some protocols that we can use to connect to the instance. we can move or add. These are already here by default. So after we have finished that, we will configure the storage for the instance and some more advanced configuration details. And then you just simply click on launch instance. And the reason we set up the instance last is that it relies on all the previously created components, the VPC, the subnet, the internet gateway, and the routing table to be configured. So you'd simply click on launch instance. We already have an instance here, so you can just go back. To and then you go to instances. So after your instance would have been created, it will take like 2 minutes to get running. It will show running here. You can just straight away select it and then just click connect. There are many different ways you can connect to the EC2 instance. You can even connect to the EC2 instance through virtual coding environments like Visual Studio Code. But the easiest way is to just simply connect through the user interface here. We'll click connect. And right now it's loading the Linux bash terminal, so we can access this virtual computer that we have created on another cloud. So now after we have connected to our EC2 instance, we will be running our web application. So the easiest way is to have your web application placed in a repository on GitHub. After that, I will run you through a series of commands where you can clone your GitHub repository here and have your application run here on Apache. First of all, it's preferable that you update the system just in case there's any new security measures in a new update. So you use this sudo yum update -y command. And then you would use this command, sudo install httpd, to install Apache with all of its services. After that, systemctl start httpd is to start Apache server. And sudo system enable httpd basically allows Apache to run on boot. So the second you start. Next, you would install Git. So this would allow you to clone your codes from your repository. Obviously, some of the outputs here would not be the same if you tried it yourself because we've already completed this on this EC2 instance. After that, you would use this command here, git clone, and then you would put in the link to your GitHub repository, which has your web application codes. It is very important also that you have a code, a file with the name index.html so that it can read it first. There's two different ways here. So one is using the SSH key and another one using the HTTPS method. So after you have cloned your repository, you would change your directory to your repository. And then you would move all your files to the root file in Apache. And after that, you can restart Apache just as a precaution. And then if you go to your EC2 instance here and you click open address, it will open your web application, which we can demo right here. And that should be it. Thank you.
Hello everyone. Let's discuss phase 4 of our project. It focuses on autoscaling, which helps maintain the performance of cloud application by automatically adjusting the number of EC2 instances based on demand. Let's do it together. In the EC2 service, go down and choose autoscaling groups. Click on autoscaling groups, give it a name, with up ASG. Uh, and let's now we need to attach a launch template that defines the EC2 instance setup, like the type, instance type, security groups, AMI, kpair name, click on next, configure network and subnets. Let's choose the VPC and the subnets. Next. And now we need to attach an elastic load balancer. We already set up an ELB in phase 3. Now we have to link it on our ASG to distribute traffic across multiple instances. Let's link it. Now it is checked. Define a time period of 300 seconds for the system to check the health of new instances, ensuring they are ready before monitoring begins. And turn on elastic answer check. Enable monitoring and next. Now uh, let's set up the auto scaling policies. Desired capacity, the initial number of instances, let's make it 2. And the minimum desired capacity, let maximum make it 6. Target scanning policy, use target time to scale based on CPU usage or other methods. Let's keep it, for example, 60. And instance learner 300. And next, next. Finally, uh, after reviewing all settings, create our auto scaling group. Let's create it. Click on create auto scaling group. It takes a while. And ta-da! This is our auto scaling groups. Please set up ensures that our application automatically adjusts to handle increased traffic, providing stability and efficiency. This is the good detail. And as we can see, it is our auto scaling groups. It includes 2 instances. Let's see it. The instances, instance management.